Good morning. I'm Viji, Assistant Professor, Department of Computer Science and Business Systems. Now I'm going to handle the topic of Turing machines in automata. So the main introduction for the Turing machine is Alan Turing is the father of this Turing machine model. This Turing machine model is an automata concept. It is capable of enumerating some arbitrary subset of valid strings of an alphabet. A Turing machine is a general example of a CPU, that is central processing unit in a computer, that controls all data manipulations done by a computer. The main tuples of Turing machine is it is a collection of seven tuples. Those seven tuples are nothing but capital Q, tau symbol, small letter B, epsilon symbol, transition symbol Q naught and F. Here, in which capital Q is nothing but a finite set of states. Second one is tau symbol. It is a finite and a non-empty set of tape alphabetical symbols. Then small letter B is nothing but blank symbol. It represents blank symbol. Even we can give the triangular symbol or any hyphen mark also. It represents the blank symbol. It is mainly used as a n marker for the inputs. Fourth one is the summation. It is defining the finite set of input symbols. The transition symbol, that is represents the mapping functions. Q naught is nothing but the initial state and the capital F is the final state. Here, the main description of the Turing machine. The Turing machine is a mathematical model, a machine that mechanically operates on the tape data structure. In this tape, there is the symbols which the machine can read or write only one at a time using the tape head. For each and every tape, we will be having the tape head. Using the tape head, it can be moved right side or the left side, and each whatever operations you can do with the tape means you can read the input and write the input at one time. So here we are using the tape head. This tape head is mainly over a particular square on a tape, only a finite stretch of squares. The instructions to be performed over the scanned squares. This tape is divided into cells, one next to the other, each cell that containing the symbols from some finite alphabets, the head that can read and write the symbols on the tape and move the tape from left to the right one cell at a time. At a time, we can move only one side, left side or the right side. In some models, the tape heads can move at both the directions, and sometimes the tape is stationary. There is some state control which can be in any one of the finite number states. The finite number of states is represented by the capital letter Q. The set capital Q that contains the three special states. One is a start state, next is the accept state, and third is the reject state. The tape alphabet that contains the blank symbol that represents some elements are present or it used to terminate the input strings. This is a diagrammatical representations. We will have the state control. Through the tape, we can inbuild various input strings into the tape. These square symbols are nothing but the blank symbols through which we can able to, by using the tape head, we can move from one input string to the other input string, and also we can connect to the various tape head also. The instantaneous description, that is, instantaneous description is nothing but the one input. If you are giving to one state, it moves more some direction. It should move either to the towards left side or the right side, and it moves on to the next state. That representation already we have seen in the finite automata. When one state it gets some input and move on to the other state, like the same thing here also. One input like Q naught, it takes the input A. This state takes the input A and move on to the next state Q1, and either this thing should be changed as a capital A by moving the left side. Here we are going to read and write operations. Either the small letter A as it is, we can keep it as the same in the same input, or else we can able to read or we can able to write or some other input symbols also. Like that here also we are writing the input symbol capital A when move on to the next state by moving the left side of the tape. Here we are taking one example. Construct a Turing machine which accepts the language A, B, A over the given input alphabets A and B. Let us assume that this input text exists string ABA is placed like this in the tape. ABA. This delta symbol, this represents a blank, that is the end of the string. It represents the end of the string, or we have to halt here. That one we are representing here by using blank symbol. So here this arrow mark, this represents the tape head. So from reading from one input to the other input, we have to move towards the left side. So this one we have to understand. Whenever you are using the Turing machine, you should know the basic concepts under the that is representation, how to write the transition Q naught or any other state. If it gets the input value, it moves on to the next state. Either in that state, you can keep as it is the inputs, or you can rewrite something, and you have to tell about which side you have moved the tape head, either left side or the right side. Here, Q naught, if you are giving the input A and move on to the right side, this input is as it is you are keeping, that's just reading the input A here, no changes here, and move on to the right side. It goes to the next state. Here, from here, Q1 state, you are giving the input B. Again, we are just read out the same input. No need to write or rewrite anything. Move on to the right side. If means it move on to the next third state Q2. If you give the input symbol small letter A from Q2 state, it move on to the Q3 state. Again, we are just read that input and move on to the left side. Finally, what is our actually our example? A, B, A. I accepted all the alphabets A from here to here, B from Q1 to Q2, and A from Q2 to Q3. Finally, we should have some halt symbol or empty symbol delta. That also we have just read to that other same symbol. Then it move on to the next state, S state, that is a halt state. So such a way we are able to move the or read or write a string in a format by using the Turing machine. In step-by-step representations of the same example to construct the Turing machine for the input strings that they have given us A, B, A. Here the start state is a Q1. If you are given the input A, no need to change anything as it is, keep the A like that and you move on to the next state Q2. Here in which you are going to read the input as B as it is, you keep the input B and move on to the next string next to input values. For that you have to move the tape head right. For that only they are representing here as a right side. And when it reaches a blank symbol, the overall inputs is being overed, that representing the blank symbol. Finally it reaches the halt state. So this is a transition table representations. For that you need to mention the states in the column wise and the input values in the row wise. Here we are having the inputs like A, B, or that is small letter A, small letter B, and the del symbol. Here it represents blank letter or the end of the string. So from one state to other state, what is the process you are doing? Either you are going to change or read or write, and we are going to move left or right. Whatever process we are doing in the same way, you have to represent it as in a table format. This is a transition table representation. Another one example we are taking is a palindrome, that is constructed Turing machine for checking a palindrome for a string even length. What is the meaning of the palindrome here? So whenever you're giving the input, for example, you are taking the input as like a mom, um, then what is the reverse string value is MOM. Forward string value also MOM. And also some examples like Madam and Malayalam. These are the examples for the palindrome. So here you are going to check the same palindrome strings by using the Turing machine. For this, we are using the logic. Compare the each and every, because the first letter, when it's reversed also, the first letter and the last letter should be the same. middle letter should be the same. The first letter and the end other letters should be the same, because one proper format, the forward letters and the backward letters, everything should be the same positional letters. So for that we are using that formula. Whenever you are reading the first letter, you move on till the end until the blank symbol and move towards the left side. Then first letter and the last letter should be the same. So once cancel the first letter, move towards the end of the blank symbol and move towards the left and cancel the other symbol. Then again move on to the come to the front first side. Here we can see by using one example. Here we have taken the example as ABA, BBA, BA. See, this is one palindrome example. For that, first this A should be moved towards this header by making it as a star or making it as a del symbol. Move towards up to move right up to till you get one blank symbol. Yes, the next step, you got one blank symbol. Then whenever you get the blank symbol, move towards the left side. For that left side, this one, this letter and this letter should be the same. So we have checked that this letter is A. Then end of the letter also A, then you make it as a bank symbol. This A should be replaced with that del symbol. Again, the tape head should be move on to the till the star symbol comes. When the star symbol comes, it shifted towards the right side. Then it move on to the B. Next one is B letter. This B letter should be converted to the star symbol. After converting it to the star symbol, then move the tape head till the end. At least it should reach a blank symbol. At that time, it reached the blank symbol. At that time, you should move towards the left side. At that time, this B should be converted into the blank symbol. So this for this A and this A we have cancelled. For this B, first letter B and the last second letter B is cancelled. Then again you move on till the star symbol comes. Then move towards the right. Pick up this A. Pick up this A. Then make this A as a star. Then move towards the blank symbol. When the blank symbol reach, move towards the left. Catches this last letter A. Then make this last letter A the del symbol. We have made this as a del symbol. Then move towards until the star comes and then move towards the right side. Catch this B and then move the tape holder towards the del symbol or end symbol or blank symbol. Then move towards the right. This for this B, you are going to cancel this B by using or replacing it with the del symbol. So whenever the all the strings has been cancelled from for first A and the last A, second B and the last second B, and each and every letters having moved towards left and right towards to reach the star symbol and the and replace with a blank symbol. Finally, there is no other symbols left. At that time the particular string is accepted, and so that it is a palindrome example. This is the Turing machine. So for it, previously we have the transition tables. Here it is the transition diagram representation for each and from one state to other state. Either you are moving towards right or the left. Each and every time you are going to convert from the previous side, that is from the top of the side of the tape, you are going to convert it into the star symbol, and the end of the string you are going to make it as a blank symbol. For each and every step that you understand from the previous one, that same thing should be represented through the state diagram. Finally, for any palindromes given, for this Turing machine will accept the palindrome examples by cancelling each and every first word towards the last word, and then the string will be accepted. If it is accepted, the particular string is a palindrome, it will end to the halt state, else it will not be ended, it will be rotated towards in the loop state. Thank you so much for listening to the Turing machine concepts. We can see about in next slides. Thank you.